Hello, dear students. Today's topic of the lecture is measuring devices. Measuring devices are devices are used to measure any properties of the bodies. For example, pressure, temperature, the viscosity, the current, the quality of the electricity, and other types. Today we're gonna consider the atmospheric pressure and the devices, the pressure generally, and devices which measure it. The atmospheric pressure is measured by a device called barometer. Thus, the atmospheric pressure is often referred as the barometric pressure. The Italian Evangelista Torricelli was the first and conclusively proved that the atmospheric pressure can be measured by inverting a mercury filled tube into a mercury container that is open to the atmosphere as shown in the figure. The pressure at point B is equal to the atmospheric pressure, and the pressure at point C can be taken to be zero since there is only mercury vapor above point C, and the pressure is very low relative to the P atmospheric and can be neglected to an excellent approximation. Writing a force balance in the vertical direction gives a frequently used pressure unit is standard atmosphere, which is defined as the pressure reduced by a column of mercury 760 millimeters in height at 0 degrees Celsius under standard gravitational acceleration. If water instead of mercury were used to measure the standard atmospheric pressure, a water column of about 10.3 meters would be needed. Pressure is sometimes expressed in terms of the height of the mercury column. The standard atmospheric pressure, for the example, is 760 millimeters of the mercury level at point C, at 0 degrees centigrade. The unit millimeter Hg is also called the torr in honor of Torricelli. Therefore, 1 atmosphere 760 torr, and 1 torr is 132.3 pascals. The manometer. We notice from the equations that is presented above that an elevation change of minus delta 0 is a fluid at rest corresponds to the delta P divided by rho and G, which suggests that a fluid column can be used to measure pressure differences. A device based on this principle is called manometer, and is commonly used to measure small and moderate pressure differences. A manometer consists of a glass or a plastic U-tube containing one or more fluids such as mercury, water, alcohol, or oil. To keep the size of the manometer in manageable level, heavy fluids such as mercury are used if large pressure differences are anticipated. Let's talk about some problem of the measuring devices. Explain why some people experience nose bleeding and some other experience shortness of breath at high elevations. First of all, we all know that the difference of pressure is very important. For example, let's pretend that you have a balloon filled with water. The density of water is close to the density of blood. If the inner pressure of the human body is stable, for example, after you go to the higher elevation or some degree above the sea level, the pressure on the outside is lower than the pressure from the inside, thus creating the differences of pressure. If the thickness of your body skin or other devices or capillaries in which the blood is placed, this creates differences, and the skin stretches, and eventually you bleed. A health magazine reported that physicians measured 100 adults' blood pressure using two different arm positions, parallel to the body and the perpendicular to the body. Readings in the parallel position were up to 10% higher than those in the perpendicular position, regardless of whether the patient was standing, sitting, or lying. Explain the possible cause for the difference. For example, different parallel to the body and the perpendicular to the body, straight out. Parallel position, up to 10% of those in the perpendicular position. Well, the position of the hand creates tension in all the muscles, and muscles require the more tension or stress in the muscles, the more blood we require, and thus creating the intensive blood and thus creating the pressure. Someone claims that the absolute pressure in a liquid of consistency doubles when the depth is doubled. Do you agree? Explain. Well, absolute pressure is not changing the double, but the sum of the pressure could be higher and would be higher if the depth is doubled. Consider two identical fans at sea level and theirs on top of the high mountain, running at identical speeds. Well, the density of the air at the high mountain is lower than the density of air in lower, which means that the mass flow rate will be lower and the volume flow rate stays the same. Another example, the water is in a tank is pressurized by air and the pressure is measured by a multi-fluid manometer shown in figure. Determine the gauge pressure of the air in a tank. Take the densities of water, and want to be well as 1,850 and 30,060 kilograms respectively. Well, this is topic for your consideration. Thank you for your attention.